want to focus in on this problem here. It's a system of linear equations. We have y equals negative x plus 1 and y equals 4x minus 14. It's two linear equations together, and we're trying to figure out what x and y would be so that both statements are true. And the instructions on this particular worksheet says to do this by elimination. So what I would advise is following these arrows here. I'm taking this equation and putting it in standard form, and then this one as well. Standard form is where you put it in the form of ax plus by equals c. So in order to do that here, I added x to both sides, or I moved this to the other side. And so same thing down here, I moved this x to the other side, or I subtracted 4x from both sides. And so that those two equations look like that. Now if I take that, what I want to do in elimination is to try to do some kind of operation on the equations so that I can add them together and get one of the variables to drop out. Well, what I notice is that they both have a y in them. So if I were to multiply the top equation by negative 1, I would get this here. And then I wouldn't have to do anything to this. I could just rewrite it. And notice that these are on top of each other. If I just add straight down, those y's are going to drop out. They're going to be 0. So I did that. This is negative 5x. This is negative 15. And if you divide by negative 5, you get 3. And all I need to do to find the y value is to take that and put it back into one of these original equations. So what I did was I put it in that top one and got negative 2. So take a peek at that. I put the 3 in x's place. Notice how I did that in parentheses there. So negative 3 plus 1 is negative 2. So my answer is the ordered pair 3, negative 2. 3, negative 2 as an ordered pair. Place 3 here and negative 2 here, 3 here and negative 2 here. Makes both of these statements true. So that is a proper solution. So this is how to solve a system of linear equations by the elimination method, also called the linear combination method. Bye.